percentage line and load regulation. What is line and load regulation? Line regulation is the ability to maintain specified output voltage even with changes in the input line voltage. In this type of regulation, only input voltage changes whereas load resistance is fixed. Output remains almost same as long as the input voltage is maintained above a certain minimum value. Mathematically, it is equals to delta V0 divided by delta V in into 100, where delta V0 is the change in output voltage for a particular change in input voltage delta V in. Next is the load regulation. It is the ability to maintain specified output voltage even in the presence of varying load. Here only input voltage is fixed and load resistance is varying. Output remains same as long as the load resistance is maintained above a minimum value. Mathematically, it is equals to VNL minus VFL divided by VFL into 100, where VNL is the null load resistor voltage, that is voltage when there is no load, and VFL is the full load resistor voltage, that is voltage when the load current is maximum. Next is how Zener diode regulates voltage. This is the circuit. Here we have a series resistor and a Zener and a load resistance are in parallel to each other. Here we apply the voltage source. This is the voltage across the Zener Vz. It is also the output voltage. Is is equals to Iz plus IL. Now this is the IV curve of Zener diode. It is to be noted from the graph that in the reverse bias mode, after a particular voltage Vz, current increases sharply without any significant increase in the voltage. So this is the property that is being used here. So case 1, line regulation, input voltage changes and load resistance is fixed in this case. Now suppose input voltage increases. Now because of that, series current Is will also increase, but no significant change in Vz. IL remain fixed, only Iz will increase. Hence, output voltage is fixed. Output voltage means voltage across Zener or voltage across RL. Actually, when voltage increases, there is an increase in current also. The extra current will be taken up by the Zener without any significant change in current across the load resistor, and the extra voltage will be dropped across series resistor Rs. So next is case 2, that is of load regulation. Here input voltage is fixed and load resistance changes. Suppose RL increases, then load current decreases. So Iz adjusts itself such that Is, that is series current, remains the same. Now since Is is same, so voltage drop across Rs, series resistor, will also be same. Hence output voltage or Vz or the product of IL into RL is also fixed. So next, to implement it experimentally. So first case is that of the line regulation. Here we need a power supply, series resistor, a combination of Zener diode and load resistance RL of 1 kilo ohm. We also need a voltmeter to measure the voltage but in this case we are going to use multimeter because it gives accurate values. So let's start. This is the series resistor RS of 100 ohm, and this is load resistance RL of 1 kilo ohm. Zener is connected in parallel to RL. Now we can start connecting. The positive terminal of the power supply is connected to one end of a series resistor RS, and P side of the Zener is connected to negative terminal of the power supply, and the other side of the resistor is connected with N of the Zener. Now multimeter needs to be connected in parallel with Zener diode or load resistance. Now here we can directly connect multimeter leads with the connecting wires, but it's always better to use crocodile clips for better contacts. So now our circuit is complete. So let's zoom it. Now this is connected to this, and these. All these four are connected. This and this. These three are also connected. Now since our circuit is complete, let's switch on the power and increase the input voltage to say 1 volt. Now rotate the multimeter knob to 20 volt DC range, so we can see the output as about 0.9 volts for 1 volt input. So we can increase the voltage and measure the output voltage. So we have increased in this case to 12 volts, but you can also increase the voltage to some 15 or 20 volts. But make sure the current through the Zener does not exceed its maximum value. The maximum current that can be passed through the Zener can be checked from its data sheet. So now we have the data, so let's plot it. So this is the graph. You can see with increase in input voltage, output voltage increases linearly initially, and thereafter it started saturating, leading to voltage regulation. So next is the load regulation. Here we don't vary the power supply, we'll set it to some 8 volts. However, load resistance will vary. Rest of the circuit remains the same. So now let's start. This is the series resistor RS 100 ohm. This is the Zener diode. Now we can also connect individual load resistances of different value, but it's better to use a resistance box since we need to vary resistance. So positive end of the power supply is connected to one end of the series resistor. P side of the Zener is connected to negative terminal of the power supply, and the N side of the Zener is connected to other end of the series resistor. Resistance box is connected in parallel to Zener diode as shown in the figure. Also, to measure output voltage, multimeter should be connected in parallel to load resistance or Zener diode like this. Now here also we are using crocodile clips for better contact. So everything is ready now. We can switch on the power and take out some resistance, say 100 ohm, and increase the voltage to 8 volts. We are not going to change this voltage. Now rotate the multimeter knob and the output voltage is 4 volt for 100 ohm load resistor. So we can increase the load resistance to say 200 ohms. So the output is 5.33 volts. So similarly we can increase the load resistance in steps of 100. So now the resistance is 300, now 400 ohm. Now for 500 ohm we are getting voltage of 6.43. For 600 we are getting 6.46. For 700 it's 6.48. For 800 and now for 900 we are getting voltage at 6.49, and finally for 1 kilo ohm we are getting output voltage as 6.50. Now we can also increase the load resistance to 2 kilo ohm, 5 kilo ohm, 10 kilo ohm. So now we have the variation of output voltage with load resistance. So we can plot it. So this is the graph. Initially output voltage increases and thereafter a certain value of load resistor it starts saturating. So now the calculation for percentage line regulation. This is the mathematical formula as discussed earlier. Now suppose input voltage is varied from 10 to 20 volts. Then output voltage changed from 6.589 to 6.75 volts in the present case. So if we put these values in the above expression, we get the value of percentage line regulation as 1.6%. So next is the load regulation. So this is the formula. Now VNL is the voltage at no load. No load means almost no current. So that can be achieved at a very high value of load resistance. So VNL is the voltage for RL is equals to 100 kilo ohm, and VFL is the voltage at full load, that is maximum current. So VFL is the voltage for load resistance at 1 kilo ohm. So putting all these values in the expression for percentage load regulation, we get the value of 0.6% as load regulation.